transparent with a single product backlog. This setting demands a cross-functional approach. So from the teams, this setting demands as cross-functional approach from the teams. Specialization in the customer domain may still happen, but we will have to dissolve once priorities and start to shift. For example, one team working on accounting functionality will have to shift from accounting features to another type if there are no longer any accounting features of the highest priority in the product backlog. Okay, so that's also shifting. Yeah, but that's good because you have to be a software developer. You have to be aware of, you have to be considering the unexpected. I would say a lot of times. Yeah. So let's go back here and so we have that multi-Scrum team, Nexus Scrum, extreme programming. Well, also extreme programming, a process framework. I think it's older. It's one of the old one compared to Scrum, and it's an agile framework that you can work iteratively with, and it has some 12 principles, and it's about 40-hour work week. It's about pair programming. It's CI/CD, continuous integration, continuous deployment. It's test driven. It's and common ownership of the code. So I think I don't remember them all of the 12 principles and it's a good framework also, in my opinion. Somehow or at least the principles are good to remember. As my experience, pair programming can be very helpful in sense of and test driven development. That's a key. It's like it's very good when you have some key functionalities that of a program that's like you have to make business software. This is a good way of saying time is money. Like us, and I'm not gonna use that. That's maybe like narrowing too bit narrow, but in some way, this I think extreme programming. Or you also have the customer non-stop, so you can always grab the phone, talk to the customer, and then get some, like evaluate on a specific feature of the product, and get their opinion immediately. That is a condition for extreme programming. So in my project we used actually elements of the extreme programming, and that tends to, they are well thought of in some way. Also, this 40-hour work week, this is I think this is a very effective framework, and I'm not sure that this is complying. I don't know what actually if this complies with Scrum. It can comply with Scrum because it's agile, so you can combining some of those elements and ensuring that they are incorporated, like pair programming, like 40-hour work week. That's really a good CI/CD common ownership. I think that it's a good framework. It has some good elements in it. And test-driven development, to me, that's one. When I discovered that this is actually a curriculum in relations to my field of study. This is or interest in the studies, or in working with object-oriented programming and development processes. Test-driven development can really help at developing some good software, and ensure the quality of it that is tested. And that can easily comply with the CI/CD during GitHub. So this is quite good. And the benefits of using it. There's a good, well thought of aspects of principles in this framework. Process and project metrics. So these are important for us to evaluate and to understand what we're doing right. I think that's validating and verification. Like for us as a to see if and to compare it with other products, and make this a quantifiable understanding of it. Because sometimes if you're you will not as a software developer and a project manager or something, you will not be developing one project, and that's, I think, if you get hold of this, that's a key. That's a very good element for to understand what the quality of the product. Like that's a way. That's our insight into what how if we're building a qualitative product. Enough is like and that's like in regards to it being a thought process and a very like a people's project, also software development. You can and it's like, I think the book state that you cannot, like if you're building some hardware or something else like physics, you go out and you can measure something very specifically, but here you have it's more difficult to go out and ensure that are we sure that the people are we have are we on track, like do we have is this product because I think the data inside is interesting, because then you can ensure for yourself, you can see that are we on the right path here, like where are we going here, how we count on the measures, how are we develop a measure, we have a measure here, we take out some errors here, we have certain errors, type number of errors here in the back end, and we will collect some errors in the front end, and then we compare them, we make them into a measurement. Now we collect the measurements, and then we make a software metric where we compare them to the amount of reviews we're making, and then we can see if what is the percentage, and then we can compare them with other projects. And I think that's because if we are able early in the process to discover if the error percentage is high, then we need to lower that, because all studies show that if errors are kept within the first part of this, I think that's a graph for it. But if we keep if we keep the errors within the start of the project, and handle those refactors, something like we keep the error handling from it being a defect, because from it being a defect that will cost the firm who we're developing to, or our maintenance team, a lot of work, a lot of money, and this is some way this is very important, and this metrics can help us uncover, like it can be our assistant, like a third eye on this process. So important to ensure metrics, to keep them and know about them, because they can really be helpful. Quality concepts, that's something I'm not quite sure of. I have something here. Let me just check it here. Quality concepts. So quality concepts. Let me just see here. Quality concepts, and they are here. Chapter 15. So that's also in regards to security. Let me just go back here, see if we have any more. I think let's see here the plan here. So I'll just go back here and see if the quality concepts. Quality, what we use here. We use the chapter 15. Okay, so, and let's go back to the comprehension. So that's, I think it's comprehensive exercise here. So chapter 15 here. So go here, quality concepts. Yeah, that's understanding quality, and this is a good center and art of the motorcycle maintenance. So it's this one example is quite good for understanding what it's about. It helped me a lot. So quality, so let me just read aloud here. Quality, what it is, yet you don't know what it is. So you know what it is, but you don't know what it is. That's contradictory, but it's saying something in the right, and So quality, you know what it is, yet you don't know what it is. But that's self-contradictory, yeah. But some things are better than others. That is, they have more quality. But when you try to say what the quality is apart from things that have it, it all goes poof. There's nothing to talk about. Obviously, some things are better than others, but what's the betterness? So round and round you go, spinning mental wheels and nowhere finding any place to get traction. What the hell is quality and what is it? Indeed, what is it? Okay. Yeah. So this is maybe a little essay and thoughts about it. So and it's yeah. So this yeah. So here it maybe it doesn't explain that much, but something here is that quality of design refers to the characteristics that designers specify for a product. The grade of materials, tolerance, and performance specifications all contribute to the quality of design. As higher grade materials are used, tighter tolerance and greater levels of performance are specified, and the design quality of a product increases if the product is manufactured according to specifications. In software development, quality of design encompasses the degree to which the design meets the function and features specified in the requirements model. So the requirements model is very important for quality. Quality of conformance focuses on the degree to which the implementation follows the design and the resulting system meets its requirements and performance goals. But are quality of design and quality of conformance the only issue that software engineers must consider? Robert Glass argues that more intuitive relationship is in the order. So, you probably know it, user satisfaction equals compliant product. Well, we have something that lives up to what we expected. Good quality, we get more than we expect, deliver within the budget and schedule. So we also have to not spend. So this is our time, and yeah, time is money, and good quality. Well, how long? Perhaps something. How long can we use it for? That sometimes also I think it states in the book here. At the bottom line, the Glass contents that quality is important. At the bottom line, Glass contents that quality is important, but if the user isn't satisfied, nothing else really matters. Okay, so that's stating that you cannot solely product. Okay, so time, resources. I'm not sure if you could do the triangle, but for compliant product, okay, we at least have to build something that's correct. Okay, we have to make a good quality and we have to deliver it within the project, the budget, and the schedule. A product's quality is a function of how much it changes the world for the better. This view of a quality contends that if a software product provides substantial benefit to its end users, they may be willing to tolerate occasionally reliability and performance problems. A modern view of software quality requires attention to customer satisfaction as well as conformance to the product requirements. Quality is so important in anything. Actually, I think you could supply it in anyhow you do it. Even though the most data software developers will agree that high quality software is an important goal. Yeah, but how do we define software quality in the most general use sense? Software quality can be defined as an effective software process applied in a manner that creates a useful product that provides measurable value for those who produce it and for those who use it. Because you're not done with developing after you develop something. So in order to make quality products, you have to. You don't do it right the first time at least. Like you have to. That involves time. Okay, so that's our quality concepts, and here we have this infamous triangle, or famous triangle, that shows the. Let me just go here and then just. So this is very important. So for us to know that testability, flexibility, portability, this is a good explanation of what we should be aware of. And these ISO standards helps us ensure that we are others also, and people can see we develop a quality products. effectiveness. So, and here are some good good factors that can help us ensure that we're staying within the rails of quality. Quality factors provide a basis for engineering software that provides high levels of user satisfaction by focusing on the overall user experience delivered by the software product. And this cannot be done unless developers ensure that the requirement specification is correct and the defects are removed early in the software development process. It's a tough part. It's tough to develop high quality products, I would say. Yeah, if you are able to incorporate this in your development, you have a quality product, I would say. This encompasses very good what a quality product is. Quality assessment. So we can do some analysis here. So the quantity dimensions of the factors presented in focus on the complete software product that can be used as a generic indication of the quality of an application. Your software team can develop a set of quality characteristics and associated questions that will probe the degree to which each factor has been satisfied. For example, ISO identifies usability as an important quality factor. You were asked to evaluate a user interface and assess its usability. How would you proceed? So although it's tempting to develop qualitative measures for the quality factors noted in section, you can also create a simple checklist of attributes that provide a solid indication that the factor is present. You might start with the sub-characteristics suggested for usability and ISO appropriateness, learnability, operability, error protection, aesthetics, and accessibility. You and your team might decide to create a user questionnaire and set of structured tasks for the user to perform, and you might observe the user while they perform these tasks and have them complete the questionnaire when they finish. We will discuss usability testing in more detail in chapter 22. To conduct your assessment, you and your team will need to address specific measurable or at least recognizable attributes of the interface. Yeah, and your task might be focused on answering the following questions. So these questions could be very useful for determining the quality, for assessing quality of your product. And here it says something about quantitative. In this preceding subsection, we have presented a quantitative measure for and perhaps that's easy. I don't know, easier, but then you can assess the data from if you have some users using it, and they you can produce some data here and some. And here it says the software engineer community strives to develop precise measures for software quality and is sometimes frustrated by the subjective nature of activity. Yeah, and that's just stating that, yeah, like in the beginning, we really have difficulty in describing quality. Subjectivity and specialization apply to determine software quality. To help solve this problem, a more precise definition of software quality is needed, as well as some way to derive quantitative measures of software quality for objective analysis. Since there's no such thing as absolute knowledge, one should not expect to measure software quality exactly, for every measurement is partially imperfect. Several software design defects can be detected using software metrics. Yeah, so here we go back to the metrics. That's why metrics could be important and interesting. And you have the tactical and strategic measures that you can apply here in some way if you want to quantify it. Yeah. Well, let's go to back here to the to our comprehension exercise here. So we are here at the quality concepts. Okay, so we go estimations of software projects. I think in many ways, I think that estimation of software projects, they they are based, as as I've tried to state before. But the way you get estimation is by pure experience, first of all, and this is I think, yeah, it lies within the software developer to know what they did before. Like they have an idea. Like there's so many factors that we can avoid by producing metrics, because then we can make better estimations, because then we know more or less, then we have a good idea of and that's based. We can use also these function points, and function points are ideal. Not metrics, but function points. Function points, because metrics can also, but function points are important to make good estimations, because if you can make you can assess the function points, the data of the function points, or make some function points calculations here. And we have if you make the complex function points analysis, that can help you very much because that different of projects are software projects, not so you where we calculate inputs, external inputs into external outputs, and then internal files, and that makes this very good. That could give us a very, and we also take some adjustment factors into it, like outer factors. I think we have here in my Excel spreadsheet here, so I could give you an example here. So we have this, and this will that's and then we scored here, and this is very fairly good for for making good estimations. Also your but pure experience is best, but function points can be also good if you're new to it, or if you make some good, like some well stated. I think you get from the function points method, and then the benefits of using it estimation is that you can you can be more responsible, precise in your estimations for prices. If you have a customer selling, we want to do this, we can help you that. We already know we did so and so we can, and when you need this, then we give a good price for the customer. So that's also important. Project management concepts. That's let me just give a good recap here on the project management concepts. So I think we go to the I think we have it here. Perhaps it's at the other one here. So let's just see if we have this, just to be sure that we do it right here. So project management. Project management here, chapter 24. So let's go here, project management concepts. So you learn management techniques required to plan, organize, monitor, and control software projects. These questions are addressed in the chapters that follow. How must people process and problem be managed during software projects? How can software metrics be used to manage a software project process? How do software team generate reliable estimates to effort, cost, and duration? That techniques can be used. So here we have a lot of interesting stuff. If you have to when you have to manage some project, and we can use a lot of different concepts here. And there's some management stuff here. So understanding stakeholder analysis, we can make that in order to get the idea of the product. Effective software project management focus on the people, product, process, and project. The order is not arbitrary. That could be more. So the manager who forgets the software engineer works is an intensely human endeavor, will never have success in project management. So we have to know that this is we have to acknowledge people, and for example, not put them into work 24/7 work. Like you have to ensure that they have some spare time. They can like be themselves. They can have some spare time. They can focus on everything else, and that can be difficult when you're a new software developer, because you won't. Then you could experience burnout, and this is not interesting for anyone, because then you also can then you don't feel that you can live up to what like you can maybe end up something. And not that this is a thing I know very much of, but that's perhaps what I see sometimes, that people tend to work to, and I've also experienced myself, that like you tend to focus on developing a good product rather than you have to remember, you have to do something else, remove your focus sometimes, and not just focus on this code problem or something, because you can end up getting stuck. And this is, so remember to take your breaks. The manager who forgets the software engineering, and this is true. A manager who fails to encourage comprehensive stakeholder communication early in the evaluation of the product is building an elegant solution for the wrong problem. Yeah, also that you have to remember. You have to communicate with each other. The manager who pays little attention to the process runs the risk of inserting competent technical methods and tools into a vacuum. Yeah, you don't have anything. That's true. The manager who begins work without a solid plan jeopardizes the success of the project. The manager who is not ready to revise the plan, then when changes arise, and doomed to fail. And this is acknowledgement, and then we can use a CMM. The cultivation of motivated, highly skilled software people has been discussed in the 1960s. In fact, the people factor is so important that the Software Engineering Institute has developed a people capability maturity model. CMM, it's so important. People like you like it's. And I think, I don't know if people neglect it or somewhat. Like I know a developer wants to develop as much as it's fun to it's fun to code. So but coding is not everything. Like that's twisted. And you have also, as a manager, I consider you have a responsibility for talking the case of to ensuring not only the product but also ensuring that the people like to work, like people that you're not suffer from burnout. That's important. So the people keep in recognition. In fact, every organization needs to continually improve its ability to attract, develop, motivate, organize, and retain the workforce needed to accomplish its strategic business objectives. The people capability maturity model defines the following key practices of okay, it's interesting. The key practices for software: people, staffing, communication and coordination, work environment, performance management, training, competency, analysis and development, career development, work group development, and team culture development, and others. Organizations that achieve high levels of people CMM maturity have a higher likelihood of implementing effective software project management practices. So, and this is not an exact science, I don't know, but you cannot. It's you have to go that way, some way. That was it. That it's not that something is right or wrong, but this is you have to focus on this. The product before a product can be planned. Product objectives and scope should be established. Alternative solutions should be considered, and technical and management constraints should be identified. Without this information, it is impossible to define reasonable and accurate estimates for the cost. An effective assessment of risk, a realistic breakdown of the product task, a manageable product schedule. So that's the tough. That's like being precise about the things. Like effective assessment of the risk. Yeah, risk is important. Realistic breakdown of the product task. Yeah, like you should not be specific, but manageable project schedule, the price, meaningful indication of progress, being clear. I think that's what I take from it. As software developer, you and your stakeholders must meet defined project objective and scope. In many cases, this activity begins as a part of the system engineering or business process engineering and continues as the first step in the software requirements engineering. Objectives identify the overall goals for the product from a stakeholder point of view without considering how these goals will be achieved. These often take the process. A software process provides the framework from which a comprehensive plan for software development can be established. A smaller number of framework activities are applicable to all software projects, regardless of the size of complexity. Even agile developers follow a change-friendly process. Okay, yeah. So a small number of framework activities are applicable to all software projects, regardless of their size. Yeah. So that's also important to note that you have to consider them. You can, yeah. And even agile developers follow a change-friendly process to impose some disciplines on the software engineering work. So remember to perhaps keep them in the. That I think that's also like some building some trust to this, that we don't forget who we are, like software developers. A number of task sets, task milestones, products, quality assurance points enables the framework activity to be adapted to the characteristics of the software project and the requirements. Okay. Finally, umbrella activities such as software quality assurance, software configuration management, and measurement overlay the process model. Umbrella activities are independent of any one of framework activity and occur throughout the process. Yeah, so they are their own. The project we conduct controlled software projects for one primary reason. It is the only known way to manage complexity, and yet, we manage complexity. Yeah. Yet software teams will still struggle in a study of 250 large software, and this is to the day also. Casper Jones founded 25 of them deemed successful in that, and how many percentage? That's 10%. In that they achieved their schedule, cost, and quality objectives. About 50 had delays or overruns below 35%, while about 175 experienced major delays and overruns or were terminated without completion. Although the success rate for present-day software projects may have evolved somewhat, our project failure rates remains much higher than it should be. So it's complex. This is very complex. To avoid project failure, software project manager and software engineers who build the product must avoid a set of common warning signs. Okay, warning signs. Let's just understand this critical success factors and lead to good product management and develop a common sense approach. People, and then we have specific chapters. I would assume here. Product, okay, interesting. So this is stakeholders. Team leaders, people, incentive activities, practitioners often make poor. Competent practitioners often make poor team leaders. Competent practitioners, I would say that's more or less correct, because they tend maybe to get involved. They simply don't have the right mix of people skills, and human states. Unfortunately, on all too frequently, it seems individuals just fall into a project manager role and become accidental project managers. Yeah, that's interesting, because I think that's what happened in my last project. That I fell into that. Shared leadership often helps teams perform better, but team leaders often monopolize decision-making authority and fail to provide team members with the levels of autonomy need to complete the task. Yeah. Don't sit there and write the code for people. Give them the space they need to work on it. James comes. So this is very, very good. Has been writing about effective leadership in various technical areas. Oh, this is very interesting. I think this is I would consider this very important. He lists 5 practices found in exemplary technology leaders. Model the way. Yeah, these are good principles. Model the way. Leaders must practice what they preach. Demonstrate commitment to the team and project through shared sacrifice by being the last one to go home each night or taking the time to become an expert on. Okay, perhaps that's important to know. Inspire and shared vision leaders recognize that they cannot lead without followers. It is important to motivate team members to tie their personal aspiration to the team goals. This means involving stakeholders early in the goal setting process. A personal aspiration means involving stakeholders early. Okay. Yeah, right, of course. Challenge the process. Leaders must take the initiative to look for innovative ways to improve their work and work with the teams. Encourage team members to experiment and take risks by helping them generate frequent small success while learning from their failures. Yes. Enable others to act, foster the team's collaborative abilities. 2. Building trust and facilitating relationships. Increase the team's sense of competence through sharing decision making and goal setting. Encourage the heart. Celebrate the accomplishments of individuals, building community team spirit by celebrating shared goals and victories both inside and outside the team. There are almost as many human organizational structures for software development as there are organizations that develop software. Yeah. Interesting fact. And this is also common process framework activities. Yeah. Process decomposition. So this is a part of the people's. Okay, good. That we weren't aware of. So that I wasn't aware of. A software team should have a significant degree of flexibility in choosing the software process model. Okay, so yeah, that is the best project and the software engineer task that probably the process model is chosen. Yeah, so we have to encourage them to choose as a leader, because that gets best involvement. A relatively small project that is similar to past efforts might be best accomplished using a single sprint approach. If the deadline is too tight, the fully functional cannot responsibly be delivered. Incremental strategy might be the best. Yeah. Good. Similarly, projects with other characteristics. Okay, so this helps us break down the way to define a good project. Once the process projects with other uncertain requirements, breakthrough technology, difficult customers, or potential for significant component reuse will lead to a selection of other process model. Yeah. Once the process model has been chosen, the process framework is adapted to it. In every case, the generic process framework discussed earlier can be used. It will work for the linear models with it. I think we should keep track here. So I'll just be going back to the to my track here, the exercise. I think we have to finish up here. So I'll just so we did some project scheduling. That's also important. Software configuration management. These are also important tasks of the software project. You can look those up and see what they can do here. Here you get the overview. So thank you for staying by. Let's see another video. See.